Section 9 of My Inventions and Other Works of Nikola Tesla, Electrical Experimenter, February to October 1919. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Lawrence Trask, Mount Vernon, Ohio, InterfaceAudio.com. Tesla on High-Frequency Generators by Nikola Tesla. This article was published in Electrical Experimenter, April 1919. Editor, Electrical Experimenter. It is to be regretted that a letter addressed to me by Mr. J. Harris Rogers, in your care, was published in the March number of the Electrical Experimenter. Although the concurrence of our views in some wireless features might have made this desirable to so wide-awake and enterprising a periodical as yours. Mr. Rogers seems to be a very appreciative gentleman, and nothing would be farther from my thoughts than to detract anything from his merit. But in a separate contribution which I expect to prepare for your next issue, I shall express myself on this subject without prejudice and in the interest of truth. However, the article by your Mr. H. Winfield Secor on America's greatest war invention, the Rogers Underground Wireless, contains a reference to a novel and original high-frequency generator of Mr. Rogers' invention. May I not, to use the President's elegant expression, call attention to the fact that this device was described by me years ago, as will be evident from the following excerpt of a communication which appeared in the Electrical Review of March 15, 1899. In speaking of circuit controllers, I said, I may mention here, based on a different principle, which is incomparably more effective, more efficient, and also simpler on the whole. It comprises a fine stream of conducting fluid, which is made to issue, with any desired speed, from an orifice connected with one pole of a generator, through the primary of the induction coil, against the other terminal of the generator placed at a small distance. This device gives discharges of remarkable suddenness, and the frequency may be brought within reasonable limits, almost to anything desired. I have used this device for a long time in connection with ordinary coils, and in a form of my own coil, with results greatly superior in every respect to those obtainable with the form of your letter. Make a few statements referring to such make-and-break devices in general, and various forms based on this new principle. I may add that a great many forms of this apparatus were constructed and employed by me for a long time, proving very convenient and useful. Water does not give particularly good results, being incapable of causing very abrupt changes, but electrolytes have the property of diminishing enormously in resistance when they are heated, and the effects are much more intense. Salts of lithium are especially efficient. Nikola Tesla, New York, February 20th, 1919. End of Section 9. Recording by Lawrence Trask, Mount Vernon, Ohio, InterfaceAudio.com. Section 10 of My Inventions and Other Works of Nikola Tesla, Electrical Experimenter, February to October 1919. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Lawrence Trask, Mount Vernon, Ohio, InterfaceAudio.com. The True Wireless by Nikola Tesla. This article was published in Electrical Experimenter, May 1919. Ever since the announcement of Maxwell's electromagnetic theory, scientific investigators all the world over had been bent on its experimental verification. They were convinced that it would be done, and lived in an atmosphere of eager expectancy, unusually favorable to the reception of any evidence to this end. No wonder, then, that the publication of Dr. Heinrich Hertz's results caused a thrill as had scarcely ever been experienced before. At that time I was in the midst of pressing work in connection with the commercial introduction of my system of power transmission, but nevertheless caught the fire of enthusiasm, and fairly burned with desire to behold the miracle with my own eyes. Accordingly, as soon as I had freed myself of these imperative duties and resumed research work in my laboratory on Grand Street, New York, I began, parallel with high frequency alternators, the construction of several forms of apparatus, with the object of exploring the field opened up by Dr. Hertz. Recognizing the limitations of the devices he had employed, I concentrated my attention on the production of a powerful induction coil, but made no notable progress until a happy inspiration led me to the invention of the oscillation transformer. In the latter part of 1891, I was already so far advanced in the development of this new principle that I had at my disposal means vastly superior to those of the German physicist. All my previous efforts with Ruhmkorff coils had left me unconvinced, and in order to settle my doubts, I went over the whole ground once more, very carefully, with these improved appliances. Similar phenomena were noted, greatly magnified in intensity, but they were susceptible of a different and more plausible explanation. I considered this so important that in 1892 I went to Bonn, Germany, to confer with Dr. Hertz in regard to my observations. He seemed disappointed to such a degree that I regretted my trip, and parted from him sorrowfully. During the succeeding years I made numerous experiments with the same object, but the results were uniformly negative. In 1900, however, after I had evolved a wireless transmitter which enabled me to obtain electromagnetic activities of many millions of horsepower, I made a last desperate attempt to prove that the disturbances emanating from the oscillator were either vibrations akin to those of light, but met again with utter failure. For more than 18 years I have been reading treatises, reports of scientific transactions, and articles on Hertz wave telegraphy to keep myself informed, but they always impressed me like works of fiction. The history of science shows that theories are perishable. With every new truth that is revealed, we get a better understanding of nature, and our conceptions and views are modified. Dr. Hertz did not discover a new principle. He merely gave material support to a hypothesis which had been long ago formulated. It was a perfectly well established fact that a circuit, traversed by a periodic current, emitted some kind of space waves, but we were in ignorance as to their character. He apparently gave an experimental proof that they were transversal vibrations in the ether. Most people look upon this as his great accomplishment. To my mind it seems that his immortal merit was not so much in this as in the focusing of the investigator's attention on the processes taking place in the ambient medium. The Hertz wave theory, by its fascinating hold on the imagination, has stifled creative effort in the wireless art and retarded it for 25 years. But on the other hand, it is impossible to overestimate the beneficial effects of the powerful stimulus it has given in many directions. As regards signaling without wires, the application of these radiations for the purpose was quite obvious. When Dr. Hertz was asked whether such a system would be of practical value, he did not think so, and he was correct in his forecast. The best that might have been expected was a method of communication similar to the heliographic, and subject to the same or even greater limitations. In the spring of 1891, I gave my demonstrations with a high-frequency machine before the American Institute of Electrical Engineers at Columbia College, which laid the foundation to a new and far more promising departure. Although the laws of electrical resonance were well known at that time, and my lamented friend Dr. John Hopkinson had even indicated their specific application to an alternator in the Proceedings of the Institute of Electrical Engineers, London, November 13, 1889, nothing had been done toward the practical use of this knowledge, and it is probable that those experiments of mine were the first published exhibition with resonant circuits, more particularly of a high frequency. While the spontaneous success of my lecture was due to spectacular features, its chief import was in showing that all kinds of devices could be operated through a single wire without return. This was the initial step in the evolution of my wireless system. The idea presented itself to me that it might be possible, under observance of proper conditions of resonance, to transmit electric energy through the earth, thus dispensing with all artificial conductors. Anyone who might wish to examine impartially the merit of that early suggestion must not view it in the light of present-day science. I only need to say that as late as 1893, when I had prepared an elaborate chapter on my wireless system, dwelling on its various instrumentalities and future prospects, Mr. Joseph Wetzler and other friends of mine emphatically protested against its publication, on the ground that such idle and far-fetched speculations would injure me in the opinion of conservative business men. So it came that only a small part of what I intended to say was embodied in my address of that year before the Franklin Institute and National Electric Light Association, under the chapter on Electrical Resonance. This little salvage from the wreck has earned me the. It was clear to me from the very start that the successful consummation could only be brought about by a number of radical improvements. Suitable high-frequency generators and electrical oscillators had first to be produced. The energy of these had to be transformed in effective transmitters and collected at a distance in proper receivers. Such a system would be manifestly circumscribed in its usefulness if all extraneous interference were not prevented and exclusiveness secured. In time, however, I recognize that devices of this kind, to be most effective and efficient, should be designed with due regard to the physical properties of this planet and the electrical conditions obtaining on the same. I will briefly touch upon the salient advances as they were made in the gradual development of the system. The high-frequency alternator employed in my first demonstrations is illustrated in Figure 1. It comprised a field ring with 384 pole projections and a disc armature with coils wound in one single layer, which were connected in various ways according to requirements. It was an excellent machine for experimental purposes, furnishing sinusoidal currents of from 10,000 to 20,000 cycles per second. The output was comparatively large, due to the fact that as much as 30 amperes per square millimeter could be passed through the coils without injury. The diagram in Figure 2 shows the circuit arrangements as used in my lecture. Resonant conditions were maintained by means of a condenser subdivided into small sections, the finer adjustments being effected by a movable iron core within an inductance coil. Loosely linked with the latter was a high-tension secondary, which was tuned to the primary. The operation of devices through a single wire, without return, was puzzling at first because of its novelty, but can be readily explained by suitable analogues. For this purpose reference is made to Figures 3 and 4. In the former, the low-resistance electric conductors are represented by pipes of large section, the alternator by an oscillating piston, and the filament of an incandescent lamp by a minute channel connecting the pipes. It will be clear from a glance at the diagram that very slight excursions of the piston would cause the fluid to rush with high velocity through the small channel, and that virtually all the energy movement would be transformed into heat by friction, similarly to that of the electric current in the lamp filament. The second diagram will now be self-explanatory. Corresponding to the terminal capacity of the electric system, an elastic reservoir is employed which dispenses with the necessity of a return pipe. As the piston oscillates, the bag expands and contracts, and the fluid is made to surge through the restricted passage with great speed, this resulting in the generation of heat as in the incandescent lamp. Theoretically considered, the efficiency of conversion of energy should be the same in both cases. Granted, then, that an economic system of power transmission through a single wire is practicable, the question arises how to collect the energy in the receivers. With this object, attention is called to Figure 5, in which a conductor is shown excited by an oscillator joined to it at one end. Evidently, as the periodic impulses pass through the wire, differences of potential will be created along the same, as well as at right angles to it in the surrounding medium, and either of these may be usefully applied. Thus, at A, a circuit comprising an inductance and capacity is resonantly excited in the transverse, and at B, in the longitudinal sense, at C, energy is collected in a circuit parallel to the conductor, but not in contact with it, and again at D, in a circuit which is partly sunk into the conductor, and may be or not electrically connected to the same. It is important to keep these typical dispositions in mind, for however the distant actions of the oscillator might be modified through the immense extent of the globe, the principles involved are the same. Consider now the effect of such a conductor of vast dimensions on a circuit exciting it. The upper diagram of Figure 6 illustrates a familiar oscillating system comprising a straight rod of self-inductance 2L, with small terminal capacities Cc and a node in the center. In the lower diagram of the figure, a large capacity C is attached to the rod at one end, with the result of shifting the node to the right through a distance corresponding to self-inductance X. As both parts of the system on either side of the node vibrate at the same rate, we have evidently L plus X, C equals L minus X, C, from which X equals L, C minus C divided by C plus C. When the capacity C becomes commensurate to that of the Earth, X approximates L. In other words, the node is close to the ground connection. The exact determination of its position is very important in the calculation of certain terrestrial electrical and geodetic data, and I have devised special means with this purpose in view. My original plan of transmitting energy without wires is shown in the upper diagram of Figure 7, while the lower one illustrates its mechanical analog, first published in my article in the Century magazine of June, 1900. An alternator, preferably of high tension, has one of its terminals connected to the ground and the other to an elevated capacity, and impresses its oscillations upon the earth. At a distant point, a receiving circuit, likewise connected to ground and to an elevated capacity, collects some of the energy and actuates a suitable device. I suggested a multiplication of such units in order to intensify the effects, an idea which may yet prove valuable. In the analog, two tuning forks are provided, one at the sending and the other at the receiving station, each having attached to its lower prong a piston fitting in a cylinder. The two cylinders communicate with a large elastic reservoir filled with an incompressible fluid. The vibrations transmitted to either of the tuning forks excite them by resonance and through electrical contacts, or otherwise bring about the desired result. This, I may say, was not a mere mechanical illustration, but a simple representation of my apparatus for submarine signaling, perfected by me in 1892, but not appreciated at the time, although more efficient than the instruments now in use. The electric diagram in Figure 7, which was reproduced from my lecture, was meant only for the exposition of the principle. The arrangement, as I described it in detail, is shown in Figure 8. In this case, an alternator energizes the primary of a transformer, the high-tension secondary of which is connected to the ground, and an elevated capacity and tuned to the impressed oscillations. The receiving circuit consists of inductance connected to the ground and to an elevated terminal without break, and is resonantly responsive to the transmitted oscillations. A specific form of receiving device was not mentioned, but I had in mind to transform the received currents and thus make their volume and tension suitable for any purpose. This, in substance, is the system of today, and I am not aware of a single authenticated instance of successful transmission at considerable distance by different instrumentalities. It might perhaps not be clear to those who have perused my first description of these improvements that, besides making known new and efficient types of apparatus, I gave to the world a wireless system of potentialities far beyond anything before conceived. I made explicit and repeated statements that I contemplated transmission absolutely unlimited as to terrestrial distance and amount of energy. But although I have overcome all obstacles, which seemed in the beginning unsurmountable, and found elegant solutions of all the problems which confronted me, yet even at this very day the majority of experts are still blind to the possibilities which are within easy attainment. My confidence that a signal could be easily flashed around the globe was strengthened through the discovery of the rotating brush, a wonderful phenomenon which I have fully described in my address before the Institution of Electrical Engineers, London, in 1892, and which is illustrated in Figure 9. This is undoubtedly the most delicate wireless detector known, but for a long time it was hard to produce and to maintain in the sensitive state. These difficulties do not exist now, and I am looking to valuable applications of this device, particularly in connection with the high-speed photographic method, which I suggested in wireless as well as in wire transmission. Possibly the most important advances during the following 3 or 4 years were my system of concatenated tuned circuits and methods of regulation, now universally adopted. The intimate bearing of these inventions on the development of the wireless art will appear from Figure 10, which illustrates an arrangement described in my U.S. Patent number 568178 of September 22, 1896, and corresponding dispositions of wireless apparatus. The captions of the individual diagrams are thought sufficiently explicit to dispense with further comment. I will merely remark that in this early record, in addition to indicating how any number of resonant circuits may be linked and regulated, I have shown the advantage of the proper timing of primary impulses and use of harmonics. In a farcical wireless suit in London, some engineers, reckless of their reputation, have claimed that my circuits were not at all attuned. In fact, they asserted that I had looked upon resonance as a sort of wild and untamable beast. It will be of interest to compare my system as first described to a Belgian patent of 1897 with the Hertz wave system of that period. The significant differences between them will be observed at a glance. The first enables us to transmit economically energy to any distance, and is of inestimable value. The latter is capable of a radius of only a few miles, and is worthless. In the first there are no spark gaps, and the actions are enormously magnified by resonance. In both transmitter and receiver, the currents are transformed and rendered more effective and suitable for the operation of any desired device. Properly constructed, my system is safe against static and other interference, and the amount of energy which may be transmitted is billions of times greater than with the Hertzian, which has none of these virtues, has never been used successfully, and of which no trace can be found at the present. A well-advertised expert gave out a statement in 1899 that my apparatus did not work, and that it would take 200 years before a message would be flashed across the Atlantic, and he even accepted stolidly my congratulations on a supposed great feat. But subsequent examination of the record showed that my devices were secretly used all the time, and ever since I learned of this, I have treated these Borgia Medici methods with the contempt in which they are held by all fair-minded men. The wholesale appropriation of my inventions was, however, not always without a diverting side. As an example to the point, I may mention my oscillation transformer, operating with an air gap. This was in turn replaced by a carbon arc, quenched gap, an atmosphere of hydrogen, argon, or helium, by a mechanical brake with oppositely rotating members, a mercury interrupter, or some kind of vacuum bulb, and by such tours de force as many new "systems" have been produced. I refer to this, of course, without the slightest ill feeling. Let us advance by all means. But I cannot help thinking how much better it would have been if the ingenious men who have originated these systems had invented something of their own, instead of depending on me altogether. Before 1900, two most valuable improvements were made. One of these was my individualized system with transmitters emitting a wave complex and receivers comprising separate tuned elements, cooperatively associated. The underlying principle can be explained in a few words. Suppose that there are n simple vibrations suitable for use in wireless transmission. The probability that any one tune will be struck by an extraneous disturbance is 1 divided by n. There will then remain n-1 vibrations, and the chance that one of these will be excited is 1 divided by n-1. Hence the probability that 2 times would be struck at the same time is 1 divided by n times n-1. Similarly, for a combination of 3, the chance will be 1 divided by n times n-1 times n-2, and so on. It will readily be seen that in this manner any degree of safety against the statics or any kind of disturbance which can be attained, provided the receiving apparatus is so designed that its operation is possible only through the joint action of all the tuned element. This was a difficult problem which I have successfully solved, so that now any desired number of simultaneous messages is practicable in the transmission through the earth, as well as through artificial conductors. The other invention, of still greater importance, is a peculiar oscillator enabling the transmission of energy without wires, in any quantity that may ever be required for industrial use, to any distance, and with very high economy. It was the outcome of years of systematic study, and investigation, and wonders will be achieved by its means. The prevailing misconceptions of the mechanism involved in the wireless transmission has been responsible for various unwarranted announcements, which have misled the public and worked harm. By keeping steadily in mind that the transmission through the earth is in every respect identical to that through a straight wire, one will gain a clear understanding of the phenomena, and will be able to judge correctly the merits of a new scheme. Without wishing to detract from the value of any plan that has been put forward, I may say that they are devoid of novelty. So, for instance, in Fig. 12, arrangements of transmitting and receiving circuits are illustrated, which I have described in my U.S. Patent No. 613809 of November 8, 1898, on a method of an apparatus for controlling mechanism of moving vessels or vehicles, and which have been recently dished up as original discoveries. In other patents and technical publications, I have suggested conductors in the ground as one of the obvious modifications indicated in Fig. 5. For the same reason the statics are still the bane of the wireless. There is about as much virtue in the remedies recently proposed as in hair restorers. A small and compact apparatus has been produced which does away entirely with this trouble, at least in plants suitably remodeled. Nothing is more important in the present phase of development of the wireless art than to dispose of the dominant erroneous ideas. With this object I shall advance a few arguments based on my own observations, which prove that Hertz waves have little to do with the results obtained even at small distances. In Figure 13, a transmitter is shown radiating space waves of considerable frequency. It is generally believed that these waves pass along the earth's surface, and thus affect the receivers. I can hardly think of anything more improbable than this gliding wave theory, and the conception of the guided wireless, which are contrary to all laws of action and reaction. Why should these disturbances cling to a conductor, where they are counteracted by induced currents, when they can propagate in all other directions unimpeded? The fact is that the radiations of the transmitter passing along the earth's surface are soon extinguished. The height of the inactive zone indicated in the diagram being some function of the wavelength, the bulk of the waves traversing freely the atmosphere. The fact is that the radiations of the transmitter passing along the earth's surface are soon extinguished, the height of the inactive zone indicated in the diagram being some function of the wavelength, the bulk of the waves traversing freely the atmosphere. Terrestrial phenomena, which I have noted conclusively, show that there is no Heaviside layer, or if it exists, it is of no effect. It certainly would be unfortunate if the human race were thus imprisoned and forever without power to reach out into the depths of space. The actions at a distance cannot be proportionate to the height of the antenna, and the current in the same. I shall endeavor to make this clear by reference to diagram in Figure 14. The elevated terminal charged to a high potential induces an equal and opposite charge in the earth, and there are thus Q lines giving an average current I equals 4 times Qn, which circulates locally and is useless except that it adds to the momentum. A relatively small number of lines, Q, however, go off to great distance, and to these corresponds a mean current of IE equals 4Qn, which is due to the action at a distance. The total average current in the antenna is thus I times M equals 4 times Qn plus 4 times Qn, and its intensity is no criterion for the performance. The electric efficiency of the antenna is Q divided by Q plus Q, and this is often a very small fraction. Dr. L. W. Austin and Mr. J. L. Hogan have made quantitative measurements which are valuable, but far from supporting the Hertz wave theory, they are evidences in disapproval of the same, as will be easily perceived by taking the above facts into consideration. Dr. Austin's researches are especially useful and instructive, and I regret that I cannot agree with him on this subject. I do not think that if his receiver was affected by Hertz waves, he could ever establish such relations as he has found, but he would be likely to reach these results if the Hertz waves were in a large part eliminated. At great distance the space waves and the current waves are of equal energy, the former being merely an accompanying manifestation of the latter in accordance with the fundamental teachings of Maxwell. At great distance the space waves and the current waves are of equal energy, the former being merely an accompanying manifestation of the latter in accordance with the fundamental teachings of Maxwell. It occurs to me here to ask the question, why have the Hertz waves been reduced from the original frequencies to those I have advocated for my system, when in so doing the activity of the transmitting apparatus has been reduced a billionfold? I can invite any expert to perform an experiment such as illustrated in Figure 15, which shows the classical Hertz oscillator and my grounded transmitting circuit. It is a fact which I have demonstrated that although we may have in the Hertz oscillator an activity thousands of times greater, the effect on the receiver is not to be compared to that of the grounded circuit. This shows that in the transmission from an airplane we are merely working through a condenser, the capacity of which is a function of a logarithmic ratio between the length of the conductor and the distance from the ground. The receiver is affected in exactly the same manner as from an ordinary transmitter, the only difference being that there is a certain modification of the action which can be predetermined from the electrical constants. It is not at all difficult to maintain communication between an airplane and a station on the ground. On the contrary, the feat is very easy. To mention another experiment in support of my view, I may refer to Figure 16, in which two grounded circuits are shown excited by oscillations of the Hertzian order. It will be found that the antennas can be put out of parallelism without noticeable change in the action of the receiver, this proving that it is due to currents propagated through the ground, and not to space waves. Particularly significant are the results obtained in cases illustrated in Figures 17 and 18. In the former, an obstacle is shown in the path of the waves, but unless the receiver is within the effective electrostatic influence of the mountain range, the signals are not appreciably weakened by the presence of the latter, because the currents pass under it and excite the circuit in the same way, as if it were attached to an energized wire. If, as in Figure 18, a second range happens to be beyond the receiver, it could only strengthen the Hertz wave effect by reflection, but as a matter of fact it detracts greatly from the intensity of the received impulses, because the electric niveau between the mountains is raised, as I have explained in connection with my lightning protector in the Experimenter of February. Again, in Figure 19, two transmitting circuits, one grounded directly and the other through an air gap, are shown. It is a common observation that the former is far more effective, which could not be the case in a transmission with Hertz radiations. In like manner, if two grounded circuits are observed from day to day, the effect is found to increase greatly with the dampness of the ground, and the same reason also the transmission through sea water is more efficient. An illuminating experiment is indicated in Figure 20, in which two grounded transmitters are shown, one with a large and the other with a small terminal capacity. Suppose that the latter be 1/10 of the former, but that it is charged to 10 times the potential, and let the frequency of the two circuits, and therefore the currents in both antennas, be exactly the same. The circuit with the smaller capacity will then have 10 times the energy of the other, but the effects on the receiver will be in no wise proportionate. The same conclusions will be reached by transmitting and receiving circuits with wires buried underground. In each case the actions carefully investigated will be found due to earth currents. Numerous other proofs might be cited which can be easily verified. So, for example, oscillations of low frequency are ever so much more effective in the transmission which is inconsistent with the prevailing idea. My observations in 1900 and the recent transmissions of signals to very great distances are another emphatic disproval. The Hertz wave theory of wireless transmission may be kept up for a while, but I do not hesitate to say that in a short time it will be recognized as one of the most remarkable and inexplicable aberrations of the scientific mind which has ever been recorded in history. End of section 10. Recording by Lawrence Trask, Mount Vernon, Ohio. InterfaceAudio.com.
Section 11 of My Inventions and Other Works, Nikola Tesla, Electrical Experimenter, February to October 1919. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Tesla Bulbs, June 1919, by Nikola Tesla. This article was published in Electrical Experimenter, June 1919. In the May issue, in his article True Wireless, Nikola Tesla mentions the forerunner of the Audion, a vacuum bulb which he used in his earlier experiments. We have been in receipt of numerous letters from many individuals interested in this bulb who desire further particulars as to its operation, etc. Accordingly, we publish herewith some excerpts from a lecture by Dr. Tesla delivered before the Institution of Electrical Engineers and Royal Institution, London, February 1892. I think it best at this juncture to bring before you a phenomenon observed by me some time ago, which to the purely scientific investigator may perhaps appear more interesting than any of the results which I have the privilege to present to you this evening. It may be quite properly ranked among the brush phenomena. In fact, it is a brush formed at or near a single terminal in high vacuum. In bulbs provided with a conducting terminal, though it be of aluminum, the brush has but an ephemeral existence, and cannot, unfortunately, be indefinitely preserved in its most sensitive state, even in a bulb devoid of any conducting electrode. In studying the phenomenon, by all means, a bulb having no leading-in wire should be used. I have found it best to use bulbs constructed as indicated in Figures 1 and 2. In Figure 1, the bulb comprises an incandescent lamp globe L, in the neck of which is sealed a barometer tube B, the end of which is blown out to form a small sphere S. This sphere should be sealed as closely as possible in the center of the large globe. Before sealing, a thin tube T of aluminum sheet may be slipped into the barometer tube, but it is not important to employ it. The small hollow sphere S is filled with some conducting powder, and a wire W is cemented in the neck for the purpose of connecting the conducting powder with the generator. The construction shown in Figure 2 was chosen in order to remove from the brush any conducting body which might possibly affect it. The bulb consists in this case of a lamp globe L, which has a neck N, provided with a tube B and a small sphere S sealed to it, so that two entirely independent compartments are formed, as indicated in the drawing. When the bulb is in use, the neck N is provided with a tinfoil coating, which is connected to the generator and acts inductively upon the moderately rarefied and highly conducting gas enclosed in the neck. From there, the current passes through the tube B into the small sphere S to act by induction upon the gas contained in the globe L. It is of advantage to make the tube T very thick, the hole through it very small, and to blow the sphere S very thin. It is of the greatest importance that the sphere S be placed in the center of the globe L. Figures 3, 4, and 5 indicate different forms or stages of the brush. Figure 1 shows the brush as it first appears in a bulb provided with a conducting terminal, but as in such a bulb it very soon disappears, often after a few minutes, I will confine myself to the description of the phenomenon as seen in a bulb without conducting electrode. It is observed under the following conditions. When the globe L, Figures 1 and 2, is exhausted to a very high degree, generally the bulb is not excited upon connecting the wire W, Figure 1, or the tinfoil coating of the bulb, Figure 2, to the terminal of the induction coil. To excite it, it is usually sufficient to grasp the globe L with the hand. An intense phosphorescence then spreads at first over the globe, but soon gives place to a white, misty light. Shortly afterward, one may notice that the luminosity is unevenly distributed in the globe, and after passing the current for some time, the bulb appears as in Figure 4. From this stage, the phenomenon will gradually pass to that indicated in Figure 5, after some minutes, hours, days, or weeks, according as the bulb is worked. Warming the bulb or increasing the potential hastens the transit. When the brush assumes the form indicated in Figure 5, it may be brought to a state of extreme sensitiveness to electrostatic and magnetic influence. the bulb hanging straight down from a wire, and all objects being remote from it, the approach of the observer at a few paces from the bulb will cause the brush to fly to the opposite side, and if he walks around the bulb, it will always keep on the opposite side. It may begin to spin around the terminal long before it reaches the sensitive stage. When it begins to turn around, principally, but also before it is affected by a magnet, and at a certain stage it is susceptible to magnetic influence to an astonishing degree. A small permanent magnet, with its poles at a distance of no more than 2 centimeters, will affect it visibly at a distance of 2 meters, slowing down or accelerating the rotation according to how it is held relatively to the brush. I think I have observed that at the stage when it is most sensitive to magnetic, it is not most sensitive to electrostatic influence. When the bulb hangs with the globe L down, the rotation is always clockwise. In the southern hemisphere it would occur in the opposite direction, and on the equator the brush should not turn at all. The rotation may be reversed by a magnet kept at some distance. The brush rotates best, seemingly, when it is at right angles to the lines of force of the earth. It very likely rotates, when at its maximum speed, in synchronism with the alternations, say 10,000 times a second. The rotation can be slowed down or accelerated by the approach or receding of the observer, or any conducting body, but it cannot be reversed by putting the bulb in any position. When it is in the state of the highest sensitiveness, and the potential or frequency be varied, the sensitiveness is rapidly diminished. Changing either of these but little will generally stop the rotation. The sensitiveness is likewise affected by the variations of temperature. To attain great sensitiveness, it is necessary to have the small sphere S in the center of the globe L, as otherwise the electrostatic action of the glass of the globe will tend to stop the rotation. The sphere S should be small and of uniform thickness. Any dissymmetry, of course, has the effect to diminish the sensitiveness. The fact that the brush rotates in a definite direction in a permanent magnetic field seems to show that in alternating currents of very high frequency the positive and negative impulses are not equal, but that one always preponderates over the other. Of course, this rotation in one direction may be due to the action of the two elements of the same current upon each other, or to the action of the field produced by one of the elements upon the other, as in a series motor, without necessarily one impulse being stronger than the other. The fact that the brush turns, as far as I could observe, in any position, would account for this theory. In such case it would turn at any point of the earth's surface. But, on the other hand, it is then hard to explain why a permanent magnet should reverse the rotation, and one must assume the preponderance of impulses of one kind. As to the causes of the formation of the brush or stream, I think it is due to the electrostatic action of the globe and the dissymmetry of the parts. If the small bulb S and the globe L were perfect concentric spheres, and the glass throughout of the same thickness and quality, I think the brush would not form, as the tendency to pass would be equal on all sides. That the formation of the stream is due to an irregularity is apparent from the fact that it has the tendency to remain in one position, and rotation occurs most generally only when it is brought out of this position by electrostatic or magnetic influence. When in an extremely sensitive state, it rests in one position, and most curious experiments may be performed with it. For instance, the experimenter may, by selecting a proper position, approach the hand at a certain considerable distance to the bulb, and he may cause the brush to pass off by merely stiffening the muscles of the arm. When it begins to rotate slowly, and the hands are held at a proper distance, it is impossible to make even the slightest motion without producing a visible effect upon the brush. A metal plate connected to the other terminal of the coil affects it at a great distance, slowing down the rotation often to 1 turn a second. I am firmly convinced that such a brush, when we learn how to produce it properly, will provide a valuable aid in the investigation of the nature of the forces acting in an electrostatic or magnetic field. If there is any motion which is measurable going on in the space, such a brush ought to reveal it. It is, so to speak, a beam of light, frictionless, devoid of inertia. I think that it may find practical applications in telegraphy. With such a brush, it should be possible to send dispatches across the Atlantic, for instance, with any speed, since its sensitiveness may be so great that the slightest changes will affect it. If it were possible to make the stream more intense and very narrow, its deflections could be easily photographed. I have been interested to find whether there is a rotation of the stream itself, or whether there is simply a stress traveling around the bulb. For this purpose, I mounted a light mica fan so that its vanes were in the path of the brush. If the stream itself was rotating, the fan would be spun around. I could produce no distinct rotation of the fan, although I tried the experiment repeatedly. But as the fan exerted a noticeable influence on the stream, and the apparent rotation of the latter was, in this case, never quite satisfactory, the experiment did not appear to be conclusive. I have been unable to produce the phenomenon with the disruptive discharge coil, although every other form of these phenomena can be well produced by it. Many, in fact, much better than with coils operated from an alternator. It may be possible to produce the brush by impulses of one direction, or even by a steady potential, in which case it would be still more sensitive to magnetic influence. Figure 6 shows a practical application of the Tesla bulb. The bulb itself, as will be seen, is excited by means of a Tesla high-frequency alternator, which, in turn, is connected to the primary of a transformer. The secondary of the transformer is grounded at one end, while the other end of the transformer connects with the Tesla bulb. Dr. Tesla, in an interview, stated that the best way to use the bulb for such experiments is when the shaft of light is in the position as shown in figures 5 and 6, at rest, but in a state of equilibrium inconceivably delicate. This is fully described above in Dr. Tesla's lecture. The inventor states that in such a condition, the shaft of light is marvelously sensitive to magnetic disturbances. Dr. Tesla informs us that a toy permanent horseshoe magnet not longer than 1/2 inch and with its poles 1/8 inch apart could with ease throw the shaft of light out of its normal direction across the whole room. In our illustration, an electromagnet is shown a few inches away from light ray, and we can imagine a slot in a screen in such a way that normally no light falls through it. If, however, very faint radio-telegraphic impulses surge through the electromagnet, the light ray will immediately become displaced and will fall into the slot. Inasmuch as this shaft of light has no inertia, it will follow exactly the dot and dash impulses surging through the electromagnet, no matter how rapidly they take place. They can then either be read off by the eye or, if desired, can be registered upon a fast-moving film. This method will, of course, only be used where the transmission is made at high speed, and where it would be impossible for an operator at the receiving end to follow the dots and dashes with the eye. The method shown by us in Figure 6, of course, represents only one. Many others can undoubtedly be evolved to use the Tesla bulb to advantage. End of section 11.
Section 12 of My Inventions and Other Works of Nikola Tesla, Electrical Experimenter, February to October 1919. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Lawrence Trask, Mount Vernon, Ohio, InterfaceAudio.com. The Moon's Rotation by Nikola Tesla, Part 1. This article was published in Electrical Experimenter, April 1919. Since the appearance of my article entitled The Famous Scientific Illusions in your February issue, I have received a number of letters criticizing the views I expressed regarding the moon's axial rotation. These have been partly answered by any statement to the New York Tribune of February 23rd, which allow me to quote: "In your issue of February 2nd, Mr. Charles E. Manier, commenting upon my article in the Electrical Experimenter for February, which appeared in the Tribune of January 26, suggests that I give a definition of axial rotation. I intend to be explicit on this point, as may be judged from the following quotation. The unfailing test of the spinning of a mass is, however, the existence of energy of motion. The moon is not possessed of such vis viva. By this I meant that axial rotation is not simply rotation upon an axis nonchalantly defined in dictionaries, but is a circular motion in the true physical sense. That is, one in which half the product of the mass with the square of velocity is a definite and positive quantity. The moon is a nearly spherical body of a radius of about 1,087.5 miles, from which I calculate its volume to be approximately 5,300,216,300 cubic miles. Since its mean density is 3.27, 1 cubic foot of material composing it weighs close on 205 pounds. Accordingly, the total weight of the satellite is about 79,969 trillion, and its mass 2,483,500 terrestrial short tons. Assuming that the moon does physically rotate upon its axis, it performs one revolution in 27 days, 7 hours, 43 minutes, and 11 seconds, or 2,360,591 seconds. If, in conformity with mathematical principles, we imagine the entire mass concentrated at a distance from the center equal to 2/5 of the radius, then the calculated rotational velocity is 3.04 feet per second, at which the globe would contain 11,474 billion short foot tons of energy sufficient to run 1 billion horsepower for a period of 1,323 years. Now I say that there is not enough of that energy in the moon to run a delicate watch. In astronomical treatises, usually the argument is advanced that if the lunar globe did not turn upon its axis, it would expose all parts to terrestrial view. As only a little over 1/2 is visible, it must rotate. But this inference is erroneous, for it only admits one alternative. There are an infinite number of axes besides its own, in each of which the moon might turn, and still exhibit the same peculiarity. I have stated in my article that the moon rotates about an axis passing through the center of the earth, which is not strictly true, but it does not vitiate the conclusions I have drawn. It is well known, of course, that the two bodies revolve around a common center of gravity, which is at a distance of a little over 2,899 miles from the earth's center. Another mistake in books on astronomy is made in considering this motion equivalent to that of a weight whirled on a string or in a sling. In the first place, there is an essential difference between these two devices, though involving the same mechanical principle. If a metal ball attached to a string is whirled around and the latter breaks, an axial rotation of the missile results, which is definitely related in magnitude and direction to the motion preceding. By way of illustration, if the ball is whirled on the string clockwise 10 times per second, then when it flies off, it will rotate on its axis 10 times per second, likewise in the direction of a clock. Quite different are the conditions when the ball is thrown from a sling. In this case, a much more rapid rotation is imparted to it in the opposite sense. There is no true analogy to these in the motion of the moon. If the gravitational string, as it were, would snap, the satellite would go off in a tangent without the slightest swerving or rotation, for there is no moment about the axis, and consequently no tendency whatever to spinning motion. Mr. Manière is mistaken in his surmise as to what would happen if the earth were suddenly eliminated. Let us suppose that this would occur at the instant when the moon is in opposition. Then it would continue on its elliptical path around the sun, presenting to it steadily the face which was always exposed to the earth. If, on the other hand, the latter would disappear at the moment of conjunction, The moon would gradually swing around through 180 degrees, and after a number of oscillations, revolve again with the same face to the sun. In either case there would be no periodic changes, but eternal day and night, respectively, on the sides turned towards and away from the luminary. Some of the arguments advanced by the correspondents are ingenious, and not a few comical. None, however, are valid. One of the writers imagines the Earth in the center of a circular orbital plate, having fixedly attached to its peripheral portion a disc-shaped moon, in frictional or geared engagement with another disc of the same diameter, and freely rotatable on a pivot projecting from an arm entirely independent of the planetary system. The arm being held continuously parallel to itself, the pivoted disc, of course, is made to turn on its axis as the orbital plate is rotated. This is a well-known drive, and the rotation of the pivoted disc is as palpable a fact as that of the orbital plate. But the moon in this model only revolves about the center of the system, without the slightest angular displacement on its own axis. The same is true of a cartwheel to which this writer refers. So long as it advances on the Earth's surface, it turns on the axle in the true physical sense. When one of its spokes is always kept in a perpendicular position, the wheel revolves around the Earth's center, but axial rotation has ceased. Those who think that it then still exists are laboring under an illusion. An obvious fallacy is involved in the following abstract reasoning. The orbital plate is assumed to gradually shrink, so that finally the centers of the Earth and the satellite coincide when the latter revolves simultaneously about its own and the Earth's axis. We may reduce the Earth to a mathematical point, and the distance between the two planets to the radius of the moon without affecting the system in principle. But a further diminution of the distance is manifestly absurd and of no bearing on the question under consideration. In all the communications I have received, though different in the manner of presentation, the successive changes of position in space are mistaken for axial rotation. So, for instance, a positive refutation of my arguments is found in the observation that the moon exposes all sides to other planets. It revolves, to be sure, but none of the evidences is a proof that it turns on its axis. Even the well-known experiment with the Foucault pendulum, although exhibiting similar phenomena as on our globe, would merely demonstrate a motion of the satellite about some axis. The view I have advanced is not based on a theory, but on facts, demonstrable by experiment. It is not a matter of definition as some would have it. A mass revolving on its axis must be possessed of momentum. If it has none, there is no axial rotation, all appearances to the contrary notwithstanding. A few simple calculations based on well-established mechanical principles will make this clear. Consider the first case of two equal weights, W and Ws, in Figure 1, whirled about the center 0 on a string S as shown. Assuming the latter to break at A, both weights will fly off on tangents to their circles of gyration, and being animated with different velocities, they will rotate around their common center of gravity, 0. If the weights are whirled n times per second, then the speed of the outer and the inner one will be, respectively, v equals 2 times r plus small r, n, and v equals 2 pi times r minus r, n, and the difference, v minus v squared, equals 4 pi times r times n, will be the length of the circular path of the outer weight. Inasmuch, however, there will be equalization of the speeds until the mean value is attained, we shall have v minus v1 divided by 2 equals 2 pi rn equals 2 pi r large N being the number of revolutions per second of the weights around their center of gravity. Evidently, then, the weights continue to rotate at the original weight and in the same direction. I know this to be a fact from actual experiments. It also follows that a ball, as that shown in the figure, will behave in a similar manner, for the two half-spherical masses can be concentrated at their centers of gravity, and M and M1 respectively will be at a distance from 0 equal to 3/8 times r. This being understood, imagine a number of balls M carried by as many spokes S, radiating from a hub H, as illustrated in Figure 2, and let this system be rotated n times per second around center 0 on frictionless bearings. A certain amount of work will be required to bring the structure to this speed, and it will be found that it equals exactly half the product of the masses with the square of the tangential velocity. Now, if it be true that the moon rotates in reality on its axis, this must also hold good for each of the balls, as it performs the same kind of movement. Therefore, imparting to the system a given velocity, energy must have been used up in the axial rotation of the balls. Let M be the mass of one of these, and r the radius of gyration. Then the rotational energy will be E equals 1/2 m times 2 pi Rn squared, since for one complete turn of the wheel every ball makes one revolution on its axis. According to the prevailing theory, the energy of axial rotation of each ball will be C equals 1/2 m 2 pi Rn squared, R1 being the radius of gyration about the axis, and equal to 0.6325 r. We can use as large balls as we like, and so make C a considerable percentage of E, and yet it is positively established by experiment that each of the rotating balls contain only the energy E, no power whatever being consumed in the supposed axial rotation, which is consequently wholly illusionary. Something even more interesting may, however, be stated. As I have shown before, a ball flying off will rotate at the rate of the wheel and in the same direction. But this whirling motion, unlike that of a projectile, neither adds to nor detracts from the energy of the translatory movement, which is exactly equal to the work consumed in giving to the mass the observed velocity. From the foregoing it will be seen that in order to make one physical revolution on its axis, the moon should have twice its present angular velocity, and then it would contain a quantity of stored energy as given in my above letter to the New York Tribune, on the assumption that the radius of gyration is 2/5 that of figure. This, of course, is uncertain, as the distribution of density in the interior is unknown. But from the character of motion of the satellite, it may be concluded with certitude that it is devoid of momentum about its axis. If it be bisected by a plane tangential to the orbit, the masses of the two halves are inversely as the distances of their centers of gravity from the Earth's center, and therefore if the latter were to disappear suddenly, no axial rotation, as in the case of a weight thrown off, would ensue. End of section 12. Read by Lawrence Trask, Mount Vernon, Ohio. InterfaceAudio.com. Section 13 of My Inventions and Other Works of Nikola Tesla. Electrical Experimenter, February to October 1919. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Lawrence Trask, Mount Vernon, Ohio. InterfaceAudio.com. The Moon's Rotation, Part 2, by Nikola Tesla. This article was published in Electrical Experimenter, June 1919. In revising my article on the Moon's rotation, which appeared in the April issue of the Electrical Experimenter, I appended a few remarks to the original text in further support and elucidation of the theory advanced. Due to the printer's error, these were lost, and in consequence I found it necessary to forward another communication, which unfortunately was received too late for embodiment in the May number. Meanwhile, many letters have reached me in which certain phenomena represented by rotating bodies, as the moon's librations of longitude, are cited as evidences of energy due to spinning motion. In revising my article on the moon's rotation, which appeared in the April issue of the Electrical Experimenter, I appended a few remarks to the original text in further support and elucidation of the theory advanced. Due to the printer's error, these were lost, and in consequence I found it necessary to forward another communication, which unfortunately was received too late for embodiment in the May number. Meanwhile, many letters have reached me in which certain phenomena presented by rotating bodies, as the moon's librations of longitude, are cited as evidences of energy due to spinning motion, i.e., proofs of axial rotation of the satellite in the true physical sense. I trust that the following amplified statement will meet all of the objections raised, and convert to my views those who are still unconvinced. The kinetic energy of a rotating mass can be determined in 4 ways, which are illustrated in diagrams, figures 1, 2, 3, and 4, and may be found more or less suitable. Referring to Figure 1, the method consists in selecting judiciously a number of points, as O1, O2, O3, etc., within the straight rod or mass M, respectively at distances r1, r2, r3, etc., from the axis of rotation 0, and calculating the square root of the mean square of these distances, its value being rg, denoted radius of gyration. The effective velocity of the mass at n revolutions per second will be v e equals 2 pi r g n, and its kinetic energy, E equals half m times v e squared equals half m times 2 pi r g n squared. In Figure 2, the mass m, rotating n times per second, about an axis 0 at right angles to the plane of the paper. In Figure 2, the mass m, rotating n times per second, about an axis 0 at right angles to the plane of the paper, is divided into numerous elements or small parts, most conveniently very thin concentric laminae, as 1, 1, 1, 2, 1, 3, etc., at distances r1, r2, r3, etc., from 0. Since the kinetic energy of each part is equal to half the product of its mass and the square of the velocity, the sum of all these elemental energies, E equals half mv2 equals half m1, v1 plus 1 half m2, v2 squared plus 1 half ma v squared 3 plus equals half m1 times 2 pi r1n squared plus half m2 times 2 pi r squared n squared plus 1 half ms 2 pi r3n squared. A different form of expression for the energy of a rotating body may be obtained by determining its moment of inertia. For this purpose, the mass m in Figure 3, rotating n times per second about an axis O, is separated into minute parts as m1, m2, m3, etc., respectively at distances r1, r2, r3, etc., from the same. The sum of the products of all these small masses and the squares of their distances is the moment of inertia I, and then E equals 1 half I W2, W equals 2 pi n, being the angular velocity. It is obvious that in all these instances, many points or elements will be required for great accuracy, but as a rule, very few are sufficient in practice. Still another way to compute the kinetic energy is illustrated in Figure 4, in which case quantity I is given in terms of the moment of inertia IC, about another axis parallel to 0, and passing through the center of gravity C of mass m. In conformity with this, the energy of motion E equals half mv squared plus half IE w squared, in which equation v is the velocity of the center of gravity. The proceeding is deemed indispensable, as I note that the correspondents, even those who seem thoroughly familiar with mechanical principles, fail to make a distinction between theoretical and physical truths, which is essential to my argument. In estimating the kinetic energy of a rotating mass in any of the ways indicated, we arrive, through suitable conceptions and methods of approximation, at expressions which may be made quantitatively precise to any desired degree, but do not truly define the actual condition of the body. To illustrate, when proceeding according to the plan of Figure 1, we find a certain hypothetical velocity with which the entire mass should move in order to contain the same energy, a state wholly imaginary and irreconcilable with the actual. Only when all particles of the body have the same velocity does the product 1/2 mv squared specify a physical fact, and is numerically and descriptively accurate. Still more remote from palpable truth is the equation of motion obtained in the manner indicated in Figure 4, in which the first term represents the kinetic energy of translation of the body as a whole, and the second that of its axial rotation. The former would demand a movement of the mass in a definite path and direction, all particles having the same velocity, the latter its simultaneous motion in another path and direction, the particles having different velocities. This abstract idea of angular motion is chiefly responsible for the illusion of the moon's axial rotation, which I shall endeavor to dispel by additional evidences. With this object, attention is called to Figure 5, showing a system composed of 8 balls M, which are carried on spokes S, radiating from a hub H, rotatable around a central axis 0 in bearings supposed to be frictionless. It is an arrangement similar to that before illustrated, with the exception that the balls, instead of forming parts of the spokes, are supported in screw pivots, which are normally loose but can be tightened so as to permit both free turning and rigid fixing as may be desired. To facilitate observation, the spokes are provided with radial marks and the lower sides of the balls are shaded. Assume first that the drawing depicts the state of the rest, the balls being rotatable without friction, and let an angular velocity, W equals 2 pi n, be imparted to the system in the clockwise direction, as indicated by the long solid arrow. Viewing a ball as M, its successive positions 1, 2, 3 to 8 in space, and also relatively to the spoke, will be just as drawn, and it is evident from an inspection of the diagram that while moving with the angular velocity W about 0 in the clockwise direction, the ball turns with respect to its axis, at the same angular velocity, but in the opposite direction, that of the dotted arrow. The combined result of these two motions is a translatory movement of the ball, such that all particles are animated with the same velocity, v, which is that of its center of gravity. In this case, granted that there is absolutely no friction, the kinetic energy of each ball will be given by the product of 1/2 m times v squared, not approximately, but with mathematical rigor. If now the pivots are screwed tight and the balls fixed rigidly to the spokes, this angular motion relatively to their axis becomes physically impossible, and then it is found that the kinetic energy of each ball is increased, the increment being exactly the energy of rotation of the ball on its axis. This fact, which is borne out both by theory and experiment, is the foundation of the general notion that a gyrating body, in this instance ball M, presenting always the same face towards the center of motion, actually rotates upon its axis in the same sense, as indicated by the short full arrow, but it does not, though to the eye it seems so. The fallacy will become manifest on further inquiry. To begin with, observe that when a mass, say the armature of an electric motor, rotating with the angular velocity w is reversed, its speed is minus w, and the difference w minus times minus w equals 2 times w. Now, in fixing the ball to the spoke, the change of angular velocity is only w. Therefore, an additional velocity w would have to be imparted to it in order to cause a clockwise rotation of the ball on its axis in the true significance of the word. The kinetic energy would then be equal to the sum of the energies of the translatory and axial motions, not merely in the abstract mathematical meaning, but as a physical fact. I am well aware that, according to the prevailing opinion, when the ball is free on the pivots, it does not turn on its axis at all, and only rotates with the angular velocity of the frame when rigidly attached to the same. But the truth will appear upon a closer examination of this kind of movement. Let the system be rotated as first assumed and illustrated, the balls being perfectly free on the pivots, and imagine the latter to be gradually tightened to cause friction, slowly reducing and finally preventing the slip. At the outset, all particles of each ball have been moving with the speed of its center of gravity, but as the bearing resistance asserts itself more and more, the translatory velocity of the particles nearer to the axis 0 will be diminishing, while that of the diametrically opposite ones will be increasing, until the maxima of these changes are attained, when the balls are firmly held. In this operation we have thus deprived those parts of the masses which are nearer to the center of motion of some kinetic energy of translation, while adding to the energy of those which are farther, and obviously the gain was greater than the loss, so that the effective velocity of each ball as a whole was increased. Only so have we augmented the kinetic energy of the system, not by causing axial rotation of the balls. The energy E of each of these is solely that of translatory movement, with an effective velocity VE as above defined, such that E equals half mv(e) squared. The axial rotations of the ball in either direction are but apparent. They have no reality whatever and call for no mechanical effort. It is merely when an extraneous force acts independently to turn the whirling body on its axis that energy comes into play. Incidentally, it should be pointed out that in true axial rotation of a rigid and homogeneous mass, all symmetrically situated particles contribute equally to the momentum, which is not the case here. That there exists not even the slightest tendency to such motion can, however, be readily established. For this purpose I would refer to Figure 6, showing a ball M of radius r, the center C of which is at a distance r from axis 0, and which is bisected by a tangential plane PP as indicated, the lower half sphere being shaded for distinction. The kinetic energy of the ball, when whirled n times per second, about 0, is, according to the first form of expression, E equals half mv(e) squared equals half m times 2 pi rgn squared, m being the mass and rg the radius of gyration. But, as explained in connection with Figure 4, we have also E equals 1/2 mv squared plus 1/2 IEW squared, v equals 2 pi rn, being the velocity of the center of gravity, c, and IC, the moment of inertia of the ball, about the parallel axis passing through C, and equal to 2/5 mi squared, so that E equals half m times 2 pi rn squared, plus half m r squared times 2 pi n squared. Neither of these two expressions for E describes the actual state of the body, but the first is certainly preferable, conveying, as it does, the idea of a single motion instead of two, one of which, moreover, is devoid of existence. I shall first undertake to demonstrate that there is no torque or rotary effort about center C, and that the kinetic energy of the supposed axial rotation of the ball is mathematically equal to zero. This makes it necessary to consider the two halves separated by the tangential plane PP, wholly independent from one another. Let C1 and C2 be their centers of gravity. Then CC1 equals CC2 equals 3/8 r. In order to ascertain the kinetic energy of the hemispheres, we have to find their radii of j2 plus m times 3/8 r squared. Hence IC1 equals IC2 equals IC minus m times 3/8 r squared equals 2/5 m times r squared minus 9/64 m times r squared equals 83/320 m times r squared. Following the same rule, the moments of inertia of the half spheres about the axis passing through the center of motion 0 can be found. Designating the moments for the upper and lower halves of the ball respectively, IO1 and IO2, we have IO1 equals m times r plus 3/8 r squared plus IC1 equals m times r plus 3/8 r squared plus 83/320 m times r squared, and IO squared equals m times r minus 3/8 r squared plus IC squared equals m times r minus 3/8 r squared plus 83/320 m r squared. Thus, for the upper half sphere, the radius of the gyration, rg1, equals IO1 divided by m equals r plus 3/8 r squared plus 83/320 r squared. And for the lower one, rg2 equals IO2 divided by m equals r minus 3/8 r squared plus 83/320 r squared. These are the distances from the center, 0, at which the masses of the half spheres may be concentrated, and then the algebraic sum of their energies, which are wholly translatory, those of axial rotation being nil, will be exactly equal to the total kinetic energy of the ball as a unit. The significance of this will be understood by reference to Figure 7, in which the two masses, condensed into points, are represented as attached to independent weightless strings of lengths rg1 and rg2, which are purposely shown as displaced, but should be imagined as coincident. It will be readily seen that if both strings are cut in the same instant, the masses will fly off in tangents to their circular orbits, the angular movement becoming rectilinear without any transformation of energy occurring. Let us now inquire what will happen if the two masses are rigidly joined, the connection being assumed imponderable. Here we come to the real bug in the question under discussion. Evidently, so long as the whirling motion continues, and both the masses have precisely the same angular velocity, this connecting link will be of no effect whatever. Not the slightest turning effort about the common center of gravity of the masses, or tendency of equalization of energy between them will exist. The moment the strings are broken and they are thrown off, they will begin to rotate, but as pointed out before, this motion neither adds to or detracts from the energy stored. The rotation is, however, not due to an exclusive virtue of angular motion, but to the fact that the tangential velocities of the masses, or parts of the body thrown off, are different. To make this clear and to investigate the effects produced, imagine two rifle barrels, as shown in Figure 8, placed parallel to each other with their axes separated by a distance, rg1 minus rg2, and assume that two balls of the same diameter, each having mass m, are discharged with muzzle velocities v1 and v2, respectively equal to 2 pi n rg1 and 2 pi n rg2, as in the case just considered. If it be further supposed that at the instant of leaving the barrels, the balls are joined by a rigid but weightless link, they will rotate about their common center of gravity, and in accordance with the statement in my previous article above mentioned, the relation will exist: V1 minus V2 divided by 2 equals pi n times Rg1 minus Rg2, n being the number of revolutions per second. The equalization of the speeds and kinetic energies of the balls will be, under these circumstances, very rapid, but in two heavenly bodies linked by gravitational attraction, the process might require ages. Now, this whirling movement is real and requires energy, which obviously must be derived from that originally imparted, and consequently must reduce the velocity of the balls in the direction of flight by an amount which can be easily calculated. At the moment of discharge, the total kinetic energy was E equals half m v1 squared plus half m v2 squared, which is evidently equal to mv3 squared, v3 being the effective velocity of the common center of gravity, from which follows that v3 equals v1 squared plus v2 squared divided by 2. The speed of revolution of the masses is, of course, v1 minus v2 divided by 2, and the rotational energy of both balls, which must be considered as points, is E equals m times v1 minus v2, m times v1 minus v2 divided by 2. The kinetic energy of translation in the direction of flight, then, is 1 half m v1 squared plus 1 half m v2 squared minus m times v1 minus v2 divided by 2 equals m times v1 plus v2 divided by 2 equals m v4 squared. v4 equals v1 plus v2 divided by 2, being the speed of the common center of gravity, so that v3 minus v4 is the loss of velocity in the direction of flight, owing to the rotation of the two mass points. If instead of these we would deal with the balls as they are, their rotational energy E1 equals E plus I W squared equals m times v1 plus v2 divided by 2 plus I times 2 pi n squared, I being the moment of inertia of each ball about its axis. As will be seen, we arrive at precisely the same result, whether the movement is rectilinear or in a circle. In both cases, the total kinetic energy can be divided into two parts, respectively, of the same numerical values. But there is an essential difference. In angular motion, the axial rotation is nothing more than an abstract conception. In rectilinear movement, it is a positive event. Virtually all satellites rotate in like manner, and the probability that the acceleration or retardation of their axial motions, if they ever existed, should come to a stop precisely at a definite angular velocity is infinitesimal, while it is almost absolutely certain that all movement of this kind would ultimately cease. The most plausible view is that no true moon has ever rotated on its axis, for at the time of its birth there must have been some deformation and displacement of its center of gravity through the attractive force of the mother planet, so as to make its peculiar position in space, relative to the latter, in which it persists irrespective of distance, more or less stable. In explanation of this, suppose that one of the balls, as m in Figure 5, is not of homogeneous material, and that it is similarly supported but on an axis passing through its center of gravity, instead of form. Then, no matter in what position the ball is fixed on the pivots, its kinetic energy and centrifugal pull will be the same. Nevertheless, a directive tendency will exist, as the two centers do not coincide, and there is consequently no dynamic balance. When permitted to turn freely on the axis of gravity, the body, of whatever shape it may be, will tend to place itself so that the line joining the two center points to 0, and there may be two positions of stability, but generally, if the center of gravity is not greatly displaced, the heavier side will swing outwardly. Such condition may obtain in the moon if it had solidified before receding from the earth to great distance, when the arrangement of the masses in its interior became subject to gravitational forces of its own, vastly greater than the terrestrial. It has been suggested that the planet is egg-shaped or ellipsoidal, but the departure from spherical form must be inconsiderable. It may even be a perfect sphere with the centers of gravity and symmetry coinciding, and still rotate as it does. Whatever be its origin and past history, the fact is that at present all parts have the same angular velocity, as though it were rigidly connected with the earth. This state must endure forever unless forces from without the luna-terrestrial system bring about different conditions, and thus the hope of the stargazers that its other side may become visible some day must be indefinitely deferred. A motion of this character, as I have shown, precludes the possibility of axial rotation. The easiest way to free ourselves of this illusion is to conceive the satellite subdivided into minute and entirely independent parts as dust particles, which have different orbital but rigorously the same angular velocities. One must at once recognize that the kinetic energy of such an agglomeration is solely translational, there being absolutely no tendency to axial rotation. This makes it also perfectly clear why the moon, provided its distance does not greatly increase, must always turn the same face to us, even without any inherent tendency nor so much as the slightest effort from the earth. Referring to the librations of longitude, I do not see that they have any bearing on this question. In astronomical treatises, the axial rotation of the moon is accepted as a material fact, and it is thought that its angular velocity is constant, while that of the orbital movement is not, thus resulting in an apparent oscillation, revealing more of its surface to our view. To a degree this may be true, but I hold that the mere change of orbital velocity, as will be evident from what has been stated before, could not produce these phenomena, for no matter how fast or slow the gyration, the position of the body relative to the center of attraction remains the same. The real cause of these axial displacements is the changing distance of the moon from the earth, owing to which the tangential components of velocity of its parts are varied. In apogee, when the planet recedes, the radial component of velocity decreases while the tangential increases, but as the decrement of the former is the same for all parts, this is more pronounced in the regions facing the earth than in those turning away from it, the consequence being an axial displacement exposing more of the eastern side. In perigee, on the contrary, the radial component increases, and the effect is just the opposite, with the result that more of the western side is seen. The moon actually swings on the axis, passing through its center of gravity, on which it is supported like a ball on a string. The forces involved in these pendular movements are incomparably smaller than those required to effect changes in orbital velocity. If we estimate the radius of gyration of the satellite at 600 miles and its mean distance from the earth at 240,000 miles, then the energy necessary to rotate it once a month would be only 600 divided by 240,000 squared equals 1 divided by 160,000 of the kinetic energy of the orbital movement. End of section 13. 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 Section